Hello friends, welcome to lecture number 1 of Frobenius method. So using this method we're going to solve this kind of equation. So here you can see how to solve this kind of equation px second order derivative of y with respect to x plus q of x. These are polynomial, p of x, q of x, r of x. These are polynomials in x, right? So now you see, before we solve this kind of equation we must know few points. That is ordinary point. What is ordinary point? If you put any point, any value x is equal to here you see, suppose we have put x is equal to x naught, then it's gonna be ordinary point. On putting x is equal to x naught here, if the value of this polynomial p of x gives non-zero value, if it is not equal to 0, then it should be ordinary point, right? So hope you have understood this. So then the next point is your singular point. What is singular point? So let me write here singular point. Here you see, this point x is equal to x naught is said to be singular if this p of x naught is equal to 0, right? So a point x is equal to x naught is said to be singular point if p of x naught is equal to 0. So if this p of x naught is equal to 0, then this point is said to be singular point. But there are two types of singular point. One is regular singular point, another is irregular singular point. So let us discuss that too as well. Now you see, this point x is equal to x naught is said to be regular singular point if p x naught is equal to 0. That must be satisfied. Also limit of x into q of x by p of x is finite, okay? And also limit of x square into r of x by p of x, that must be also finite. Then only we can say that this point is regular singular point. This point is regular singular point. Otherwise this will be irregular singular point if it is not regular, right? So hope you have understood this. Now let us solve a problem. So here you see, we need to find the nature of the singular point x is equal to -1 for this given differential equation. That means we need to find the nature, means we have to determine it is a regular singular point or irregular singular point, okay? So now let us solve this. So before we solve, please subscribe to the channel if you are new to my channel. Also share with your friends. If you like my videos, hit the thumbs up button. Also hit the bell icon. When new video will be uploaded, you get notified, okay? So thank you for watching. Just continue. So let us determine the nature. So here you see, let us solve this. So this is the given equation. Let me write the given equation first. In solution you must have mentioned you must mention this given equation, always remember that. So here what will be the px? This will be the px, this will be the qx, and this 2 is the rx, right? So here p of x is equal to x square plus, x square into x plus 1, and q of x is equal to your x square minus 1, and here r of x is equal to 2, okay? So given this is singular point, if you see x is equal to -1, so if you put f of, instead of x, if you put -1, then what you're gonna have, -1 square, then here if you put -1, right, -1 then +1, so it's gonna be 0. So this is a singular point, right? So now to determine the nature, if this is not a regular singular point, then it must be irregular. So let us check it is regular or irregular. So first, in order to check is that point regular or not, so first let us find this limit. X tends to, x naught is here -1, so x tends to -1, x into q of x by p of x, right? So that's going to be equal to limit x tends to minus 1 x into x square, q of x is x square minus 1, then divided by p of x is x square x plus 1, right? So here you see you cannot put minus 1 here now, that's going to be infinite, right? So first let us factorize this. So here you can consider this one as 1 square, and in that case you can apply a plus b into a minus b, and if you factorize then what you're going to have, so limit x tends to minus 1, then x into x plus 1 into x minus 1, right? You're going to get that after factorization, then x square into x plus 1, right? So here you can see that you can cancel this x plus 1, and this x here, x square. So then we have got limit x tends to minus 1 x minus 1 by x. That is what we have got. So now if you replace the x by minus 1, then what you're going to have, you're going to have minus 2 by minus 1, which is nothing but 2, right? Which is nothing but 2. So this is finite, right? Is finite, right? So still we cannot say it is regular or not, because we have to evaluate one more limit, that is limit x tends to minus 1 x square r of x by p of x, right? So here limit x tends to minus 1 x square, and r of x is this 2, so into 2 divided by p of x is this one, x square into x plus 1. That's what we have got, right? So here you can see clearly x square gone. So there is now limit x tends to minus 1, we have 2 by x plus 1, and this is not finite, okay? This is not going to be finite, because this cannot be cancelled out here. There is nothing in the numerator to cancel this x plus 1 in the denominator, and if you put here minus 1, that's going to be 0. Anything to the power anything divided by 0 is always infinite, okay? So hope you have understood. So if you see this is not finite, as this is not finite, that x square into r of x by p of x, its limit to x minus 1. So therefore this x is equal to minus 1 is a irregular, this is a irregular singular point. So this is the answer, okay? So this is a irregular singular point. That is what asked in this question. This is the nature of this point. So hope you have understood. Now let me show you how to solve Frobenius, how to solve this kind of equations using Frobenius method. So now how to use the Frobenius method to use this type of equations. Now first of all, first condition is x is equal to 0 must be regular singular point, right? So that must be regular singular point, x is equal to 0. This condition must be satisfied, okay? So now you see step 1. You see, we're going to consider the series solution, that using this method we're going to obtain the solution in form of series, okay? So we're going to consider the solution to be y is equal to summation from r is equal to 0 to infinity ar x to the power m plus r. We're going to consider that way, right? Then step 2, next step, we are to obtain m how to obtain m? To obtain m, first we're going to find first order derivative of y, that means dy dx, then second order derivative of y, then we're going to use these results, using these expressions or results in equation number 1, in the given equation, right? You're going to use those in equation number 1. Then step 3, equating the coefficient of lowest power of x in the identity to 0. Then we're gonna have a quadratic equation. A quadratic equation in m, okay, in m, and we're gonna solve this equation, and this is called initial equation, and solving this we're gonna obtain m, okay. Then we're gonna solve this. Then step 4, solve this quadratic equation or initial equation, okay. Then you see, after following those steps here, 4 steps, depending on the nature of the roots, that means depending on the values of m, we're going to have 4 cases. We're going to have 4 different cases. You see, first one, if m1 and m2 are not equal and their difference is not an integer, m1 minus m2 doesn't belong to, suppose, integer, doesn't belong to z. In that case, your solution will be y is equal to c1 y m1 plus c2 y m2. That's going to be the solution. So I will explain what is ym1, what is ym2, okay. So now let us take an example of this case, okay. So here you see, this is the given equation. We are to solve this equation using the Frobenius method. First, let me copy this equation, okay. So let us solve this. So here the given equation is this is the given equation. Let us take, this is an equation number 1. So as the method is already mentioned here, so we are not going to check x is equal to 0 is a regular singular point or not. So we don't need to check that if it is already mentioned in the equation that use Frobenius method. So in that case, we're going to take the solution. Let y is equal to, then we're going to consider y is equal to summation r is equal to 0 to infinity ar x to the power m plus r, right? So now if you differentiate it, that means if you find y dash, then what you're gonna have, y dash will be summation r is equal to 0 infinite, so ar is constant, so simply ar. So if you differentiate it using this formula ddx of x to the power n, which is equal to n into x to the power n minus 1, in that case what you're gonna have, here n is m plus r, then x to the power n minus 1, that means m plus r minus 1, that's what you're gonna have, right? So if you differentiate it again, let me cut it, then you're gonna obtain y triple double dash. So if you differentiate it again, then what you're gonna have, now differentiate it, so ar m plus r, then m plus r minus 1 x to the power m plus r minus 2, that's what we're gonna have. Now let us use this expression in equation number 1 in this equation. So let me take those two. Okay, so let us take this set of equations as equation number 2. Then from 1 and 2, what we're gonna have, from 1 and 2, then what we're gonna have now you see, just replace this y double dash by this expression, then what you will get. So what we have done, replace this by this, so what we're gonna have, 9x 1 minus x, y double dash, instead of that gonna be r is equal to 0 to infinity ar m plus r, so m plus r minus 1, then x to the power m plus r minus 2, right? Okay, so then now replace this y dash by this expression, then what you're gonna have, then 12 summation r is equal to 0 to infinity ar m plus r into x to the power m plus r minus 1, that's what you will get, right? Just wait, let me give it a speed. So x to the power m plus r minus 1, that is what we're gonna have. Then replace this y by this expression, then what you will get, plus 4, instead of y we're gonna have summation r is equal to 0 to infinity ar x to the power m plus r, that's going to be equal to 1. So this is the equation we have obtained from equation number 1 using 2. Okay, so that is what we have got. So now let me copy these things and let me go to the next slide. Okay, let me copy these things and let me go to the next slide. Just wait. So here is a new slide. So this is the equation we have obtained now. So let me rearrange the terms. Okay, so this is the equation we have got, right? So now what is the next step we are going to do here? So first let me simplify this. What we're going to do, this is 9, okay, not a, just multiply this 2, then what you're gonna have, then multiply that with this one as well, then what you will get. So 9x into 1, that's gonna be 9x. If you multiply here, then what you will get, then you're gonna have 9 summation r is equal to 0 to infinity ar m plus r minus 1 x to the power. Here you see, if you multiply here x, this x should be multiplied, right? Then this power will be, its power will be m plus r minus 1, right? That's what we're gonna have. Then if you multiply 9x with x, then you're gonna have 9x square. Then multiply this 9x square with this term again, then what you will get? Then you're gonna have minus, as there is minus sign, okay, you're gonna have minus summation r is equal to 0 to infinity ar m plus r into m plus r minus 1 x to the power. And here you see, when you will multiply x square with this, then you're gonna have x to the power m plus r, right? X to the power m plus r only, right? So then similarly next term is this, so minus 12 summation r is equal to 0 ar m plus r x to the power m plus r minus 1 plus 4 summation ar x to the power m plus r is equal to 0. That's what we're gonna have, right? So hope you have understood this. Now you see, this is x to the power m plus r minus 1, this is also x to the power m plus r minus 1, and from these two terms we can take common this part, this one, and here also we can take this part common, and from 9 and 12 we can take 3 common, right? And if you do so, then what you're gonna have, so let us take 3 common, and summation r is equal to 0 to infinity. We have taken ar common, and m plus r is also common. Then within bracket we're gonna have 3 m plus r minus 1. Then and on taking 3 common from 12, we're gonna have 3, right? 4. So here we're gonna have minus 4. Then this variable is also taken common outside the bracket, so x to the power m plus r minus 1, right? That's what we're gonna have. So similarly, is there anything that we can take common in remaining terms? Yes, definitely. So here you can see this part can be taken common, right? So 4 cannot be taken common here, 3 cannot be taken common, okay? So here taking this common, what we're gonna have here, minus let us take common, minus summation r from r is equal to 0 to infinity, ar is taken common. Then within bracket what we're gonna have, 9 into m plus r into m plus r minus 1. Then here we have plus on taking minus common, so this is gonna be minus, right? Minus 4. This summation part is taken common, right? Summation here r is equal to 0 to infinity, I forgot to write here, so ar is also taken common, so that's going to be 4. And most importantly, this is also taken common, right? X to the power m plus r, which is equal to 0. That is also what we have got. So just let me write this one here. Just wait. Now. So this is the equation we have got, okay? So now let us simplify this. Now let me copy these things and let me go to the next slide, okay? Let me go to the next slide. So here you see, so this was the equation that we have obtained. So now if you simplify this, then what you're gonna have, 3 summation r is equal to 0 to infinity ar m plus r. So If you simplify this, then what you're gonna have here, so thrice m plus thrice r, then minus 3 minus 4, that's gonna be minus 7, right? X to the power m plus r minus 1, then minus summation r is equal to 0 to infinity ar, then what you will have here, so if you multiply this two, 9 into this 2, then what you're gonna have, 9 m plus r whole square, right? Then minus 9 m. Here you see, if you multiply this one with minus 1, then you're gonna have minus 9 m plus r, then what we're gonna have, minus 4 here, right? Minus 4, that's it. And I have missed that part. Here you can see, let me write here this one, then we're gonna have x to the power m plus r, which is equal to 0. So that is what we have got, right? So now let me write these things here. Now assume this way, assume this part as this way, 9x square minus 9x minus 4. You can assume that way, right? If I am not wrong. Okay, so in that case, so 3x square minus 3x minus 4, right? So you can factorize this in this way, that thrice x square sorry, there should be a 3 another. Okay, so you can just wait. So you can factorize this way, there should be equal sign. Okay, thrice x square minus this 3 can be written as plus minus 4 plus 1 into thrice x, then plus minus 4 into 1. So if you factorize this, then what are you gonna have, thrice x minus 4, right? Thrice x minus 4 into then thrice x plus 1. So this is gonna be your result. So x is nothing but your m plus r. So if you factorize this, we're gonna have 9, sorry, not 9, right, 3 m plus r in minus 4 and 3 m plus r, 3 into m plus r plus 1. That's what we're gonna have if we factorize this term. Okay, so hope you have understood this. So now let me clean these things, just wait. Okay, so hope you have understood this. So now you see, this is nothing but factorization of this. Okay, nothing new about it. Okay, just hope you have understood this. Now from here we're gonna equate the coefficient of lower power of x. Here you see, equating the coefficients of x to the power. What will be the lower power? If you put r is equal to 0, yeah, then you're gonna get lower power of x. So that will be x to the power m minus 1. And here you see, this is m plus r. So in order to get minus 1, m minus 1, you have to put here minus 1, r is equal to minus 1, but r cannot be negative, r starts from 0, right? So that's why we're gonna ignore this second part here, right? So in order to equate the coefficients of x to the power m minus 1, we cannot get the x to the power m minus 1 from this part. So that's why we are not going to consider this part, second summation. Yeah, we're going to take the coefficients from the first summation only. So if you put r is equal to 0, then you know, this is equating the coefficients of x to the power m minus 1 to 0, right? to 0, just you have to write putting r is equal to 0 in first summation, right, first summation. So what we're gonna have here, so we're gonna get 3. So if you put r is equal to 0 here, then what gonna be the term a naught m plus here m plus 0 will be m simply, right? Just write m. Then here this term gonna be 0, so we're gonna have twice m plus, sorry, not plus, minus 7, right? This is the coefficient of x to the power m minus 1 on putting r is equal to 0, right? That's what we have got, and we're gonna equate this to 0, right? So that is the rule. And here one more thing, remember that a naught cannot be equal to 0, it cannot be equal to 0, right? So so here, that's why what we're gonna get, and here you see a naught cannot be 0 here, so m into twice m minus 7 is equal to 0, because this is equal to 0. It is possible if there is any one term, there must be a 0, then only you will get 0 product, you will get 0. But here a naught cannot be equal to 0, because if a naught is equal to 0, then all the coefficients will be 0. So that's why a naught cannot be 0, right? A naught is not equal to 0, right? Because if you take a naught 0, then all the coefficients will be 0, because we used to express all the coefficients, all other coefficients in terms of something into a naught, right? So if a naught is 0, then other coefficients will be also 0. So that's why we cannot take a naught equal to 0 here. So now if you solve this equation, let me copy this equation, let me go to the other side. So this is the equation. If you solve it, then what you're going to have, you're going to have m is equal to 0, or twice m minus 7 is equal to 0, and which implies m is equal to 7 by 3. So here we are getting two zeros, m1 and m2. m1 is equal to 0 and m2 is equal to 7 by 3, and these two are not equal. Here m1 and m2 are not equal, and their difference is not an integer, it doesn't belong to z, right? Because if you subtract these two, then you're gonna have difference, you're gonna have fraction, so that's why it is not an integer. In that case, we're gonna use the first case, this case. So here solution will be of this form, right, as we have already discussed. So now you see, so what is the next step we need to do here? Let me go back to the previous slide. So here, as we have already equate the coefficient of x to the power m to 0, now our next step is to equate the coefficient of x to the power m, right? Next smallest power of x, that is m, after m minus 1. So we're gonna equate the coefficients of x to the power m to 0. So then in that case, what we're gonna do in order to get m, so we're gonna put here r is equal to 1, here r is equal to 1, and here we can put r is equal to 0, right? So if you do so, then what we're gonna have, so just wait, let me take this step to, let me copy this step and let me write this one on the other side. Let me write this step on other slide. Okay, so here you can see, okay, so this is the equation from where we're gonna equate the coefficients. So let me write these things here. Just wait, let me adjust a little bit. So here what we have done, okay, so just as there is not enough space, so I need to do a little bit of adjustment here. Okay, just wait. Okay, yes, done. almost done. So here you can see now we have got enough space to proceed further. So let me go up here. So now equating the coefficients of x to the power m to 0. So in that case, what are we going to do? We're going to put r is equal to 0 and r is equal to sorry, not 0, r is equal to 1 and then r is equal to 0 respectively in the first summation and second summation. Okay, so do write the word summation, though I have used the symbol. Okay, so in order to save time I have written the symbols only, right? So now here you see what if you put r is equal to 1 here in the first summation, then what you're going to have here, then you're going to have 3a1 then m plus 1, then if you put 1 here, then you're going to have thrice m plus 3 minus 7, that's going to be equal to minus 4. So directly let me write minus 4, then minus, if you put r is equal to 0 here, okay, r is equal to 0 in the second summation we have put r is equal to 0, right? So in the first summation we have put 1, in the second summation we have put r is equal to 0. So why 1 and 0? If you put 1 here, then it's going to be x to the power m, and if you put 0 here, then it's going to be x to the power m, right? So both the powers on both in the both summation, x to the power, the power on x must be the same. Okay, so that is the concept behind it. So now here you see a0, then just wait, so 9 m plus 0, that's gonna be m square here 9, so again put here 0, then you're gonna have 9m minus 4, that's what we have got. So that's equal to 0, right? That's what we have got. So now let me copy this. Okay, just wait, let me copy this and let me go to the new slide. So here is the new slide, and let me simplify this. So if you simplify this, then if you shift this term to other side, then what you're gonna have, then you're gonna get this, right? Okay, so hope you have understood what we have done. We have just shift this term to other side, then it's gonna be positive, right? So that's what we have done. Just you can write like this way, just this. Now here we're gonna get equal sign right here. So hope you have understood this. So then in that case you can see thrice a1 m1 plus thrice m minus 4, and if you say, if you factorize this, splitting the middle term, how you can split the middle term? Just simply you can say thrice m square plus minus 4 plus 1 into thrice m plus minus 4 into 1, right? Is that correct? So this is x square plus a plus b into x plus a into b, that is x plus a into x plus b, right? X plus a into x plus b. If you apply that, then you must got here, this is x, this is a, this is b, this is x, this is a, this is b, right? So that's why thrice m plus a is minus 4 here, so thrice m minus 4, and the other is thrice m minus not minus, plus 1. This is minus 4 plus 1, right, into plus 1. So this is b. So hope you have understood. So now, so let me write this result here. So what we have got, thrice m minus 4 and thrice m plus 1. right? So here these two cancels, thrice m minus 4, thrice m minus 4 gone. So we have a1 is equal to, sorry, I have missed the a naught here, there should be a naught, okay. So that's going to be equal to thrice m plus 1 divided by 3 into m plus 1, and there should be a naught. So that's what we have got. This is a naught, right? So now what we will get, just wait, let me now let me go to the previous slide again. So here you see in this equation, let me take this equation again, just wait, let me copy this equation again, right? We're gonna need this equation again, right? So that's why I'm copying. Okay, just wait, just wait, just wait, just wait. Okay, it's done almost. Okay, so let me copy this and let me go to the next slide. Okay, so here's the term. So now you see, what if we replace this r by r plus 1 and we replace this r by r only, okay? Then here you're gonna have x to the power m plus r, and this remains x to the power m plus r, right? That's what we're gonna do. So equating the, now what we're gonna do, equating the coefficients of x to the power m plus r, just put r is equal to r plus 1 in first summation, and r is equal to r in the second summation. That's what we have. So use the word summation here, okay, instead of the symbol. So now you see, so as we have not enough space here, let me go to the next slide. Let me copy these things and let me go to a new slide, okay? So hope you're gonna understand this thing. Okay, just let me paste it. Okay, so here is our content. So now what we're gonna have, so replace this r by r minus 1, sorry, not r minus 1, what we have done, r plus 1, sorry, r plus 1. So this is r plus 1, right? So we're gonna keep the r as r in the second summation, and here it is 3 into r plus 1 instead of r. So that's going to be thrice r plus 3, and plus 3 minus 7, that's going to be minus 4, right? So in that case 3's, so here 3 a r will be r plus 1, and m plus r plus 1, instead of r we have put r plus 1, then thrice m plus, if you put here r plus 1, then you must got thrice r minus 3, plus 3 minus 7, right? And plus 3 minus 7, make it minus 4. Let's make it minus 4. So you just wait, here it's gonna be minus 4, then x to the power m plus r, right? And the next part, from the next summation, second summation, what are we gonna get? So we kept this one as it is because there is already x to the power m plus r, right? So here we will get ar 9m plus r whole square minus 9 into m plus r minus 4. That's what we have got, equal to 0, equating these things with 0. So now if you simplify this, then what you will get, so a r plus 1 will be equal to ar, so we're going to shift this term to that side, and if you simplify this as we did here, as we have done here, okay, so instead of m, now we have m plus r. So that if you apply the same method to simplify, factorize that, sorry, then you're gonna have here thrice we had here we had got thrice m plus 1. So instead of m plus 1 there will be only m plus r, not only m. Now we will get here you see, compare with thrice m minus 4, instead of m we have got m plus r. That's it. So here we're gonna have minus 4 and then thrice m plus 1. Here m will be replaced by m plus r plus 1. That's gonna be the factorization of this. Okay, so now here m plus r plus 1 and we have thrice m plus 3 r minus 4. That's what we have, and also we have a 3 here. Okay, now you see, if you multiply this 3 here, then thrice m plus thrice r minus 4, that's what you will get, and this is same as this one, so you can cancel these two, right? So you can cancel. Then after cancelling these two terms, what we will get, let me go to the next slide again. Let me copy this. Let me go to the next slide. Here is the next slide, and we have ar plus 1, then we have ar. So let me write add this one at the end. So we have thrice m plus thrice r plus 1. Just multiply this 3 with this. Okay, then divided by 3m plus 3r plus 3. So I multiplied this 3 and this is ar, right? So hope you have understood this. Now what is the next step? So we have already got a1, right? So this is a1. Here you can see this is a1. So we have already got a1. This is the value of a1. Okay, now you see, so we have got two roots, m is equal to 0 and m is equal to 7 by 3. So for m is equal to 0, m is equal to 0, what gonna be the value of a1? So a1 will be equal to, if you put m is equal to 0 here, then what you're gonna have, so this thing is gonna be 0, only 1 left here. 0 plus 1, 1 3 is a 3, so that's what you will get. So 1 by 3 into a naught, right? So 1 by 3 into a naught, right? Now what going to be the value of ar plus 1 if you put m is equal to 0? If you put m is equal to 0 here, then what going to be the value of this ar1 plus ar plus 1? So let me show you. ar plus 1, that's going to be equal to thrice r plus plus 1 divided by thrice r plus 3 into ar. That's what we're going to have. So as we have put m is equal to 0, so these two terms going to be 0, right? So now you see, let's find it a2, a3, a4. Okay, so how to obtain the a2? We have already got a1, right? So how to obtain a2? So if you put r is equal to 1, then you will get here, if you put r is equal to 1 here, then you're going to have a2, right? a2 is equal to thrice r. So on putting r we are getting a2, right? On putting r is equal to 1 we are getting a2. So that's why if you put here r is equal to 1, then what going to be the value here? 3 1 is 3 plus 1 by 3 plus 3 into a1. That's what we're going to have. Now what we're going to do here, we're going to replace this a1 by this value of a1, put this one here, then what you will get, this value will be here it is 4 by 6 into 1 by 3 a naught. That is what we're going to have, and it's become 4 by 18, or you can cancel, right? No, yes, you can cancel. So what you can do here, 2 to the 4, 2 3 is the 6. So after cancellation you can have 2 by 9 a naught. So that's what we have got, a2 is equal to. So similarly we can find a3 as well. Let me copy these things and let me go to the next slide. Yeah. Okay, now let me go to the next slide. So let's find a3. How to get a3? If you put here r is equal to 2, then you're gonna have a3, right? So putting r is equal to 2, we're gonna have a3. a3 will be equal to 3 into 2 plus 1, 3 into 2 plus 3. So what we have done, we have put r is equal to 2, right? So into a2, right? So now replace this a2 by this value of a2. This is equal to a2, right? So then it's gonna be 7 by 3 to the 6 plus 3, 9 into 2 by 9 a naught, right? So hope you have understood this. Then it's gonna be 14 by 81 a naught. Similarly we can find a4 as well, and so on, right? So now if we use these values in this equation, so let me take this as equation number 2. So just let me copy this equation. So here you see this is the equation, right? So let me keep it aside here. So putting these values in equation number 2, so this equation can be written this way, right? You can see this y can be written as just from equation number 2, it can be written as y is equal to, if you expand it, you're gonna have a naught x to the power m plus a1 x to the power m plus 1 plus a2 x to the power m plus 2 and a3 x to the power m plus 3 and dot dot dot, so on, right? So up to infinity, right? So if you use this value of m is equal to, for m is equal to 0, if you use this value a is equal to 1, as a1 a2 a3 here, okay, then what gonna be this result? So what we're gonna do, we will write here putting these values in equation number 2, what we can write. So just replace the a naught by its value. A naught is equal to, so a naught remains a naught, sorry, a naught remains a naught. Then a1 is equal to, what is a1 here? A1 is 1 by 3 a naught. So let's put here 1 by 3 a naught. So it's going to be 1 by 3 a naught, right? Then m is equal to 0 here, so that's why here it's gonna be 0. That's why only you're gonna have x naught is nothing, x to the power 0 is nothing but 1, so we can simply have a naught here, and here it will be if you put 0, m is equal to 0 here, 0 plus 1, that's gonna be 1, because we had here, you see, we had m plus, as this one m1 plus m plus 1, so on putting m is equal to 0, so we're gonna have x to the power 1, that means simply x, you can say. So now you see, and here this a2 can be replaced by this value, and if you use this value here, and if you put m is equal to 0 here, then what is going to be this? this term gonna be like this. So a2 is equal to here 2 by 9 a0, and this is gonna be 0, so that's why x square, you can simply write x square, right? So similarly you can replace a3 as well. Now if you replace a3 by its value, that is the value here, you can see 14 by 81, and if you put m is equal to 0, 0 plus 3, that's going to be 3, so here x will be 3. That's what we have got. So this is the value of m at m is equal to this is the value of y at m is equal to 0. So hope you have understood this. So similarly we're going to have another solution. Okay, so now we're going to have another solution. Now let me copy these things. Here you see, let me go back to this slide and let me copy these things again. Right, now let me go to new slide. Here you see, so we will let us find the value of ar plus 1 and a1 for m is equal to, for the next root, that is m is equal to 7 by 3, right? So let me arrange these things a little bit. Wait, so for m is equal to 7 by 3, if you replace this m by 7 by 3, then what going to be the result? Then 3 into 7 by 3, if you replace m, then this 2 going to be cancelled, plus thrice r plus 1, then 1 plus 7, that's going to be 8. We're going to have in the numerator 3r plus 8, right? And in the denominator, if you replace this by 7 by 3, if you replace this m, then this is going to be thrice r plus 3. So here this 3 will be cancelled, 7 plus 3, that's going to be 10. So in the denominator we're going to have 3r plus 10. That's what we're going to have. So 3r plus 8 by 3r plus 10, right? So that's going to be the value of ar plus 1. Ar plus 1 will be equal to 3r plus 8 by 3r plus 10. That's what we have got into ar, right? So hope you have understood this. Now similarly a1, if you put here 7 by 3, then 7 by 3, this 2 3 will be cancelled, right? Then 7 plus 1, that's going to be 8, right? That's going to be 8. Similarly, if you replace this 7 by 3, then 3 will be cancelled on multiplication of 3, and there will be 3 ones are 3, 7 plus 3 10, so 8 by 10, that's what you're going to have. So you're going to have 8 by 10, right? 8 by 10 and not. So on cancelling this to here you see, you can write here 4 by 5, right? So 4 by 5 a not, that's what you're going to have. So similarly, let us obtain a2. We have already got a1, so let's find a2. So how to find a2? So in order to find a2, you have to put here r is equal to 1, right? So let's put r is equal to 1. So putting r is equal to 1, we can have a2. So if you replace this r by 1, then what going to be the value? 3 into 1 3 plus 8. So 3 1 is 3 plus 10. ar, that's r is replaced by 1. So now this a1, put this value of a1 here, then what you're gonna have? 11 by 13. a1 is 4 by 5 a naught, right? So that's going to be 44 plus 65 a naught. That's what we're going to have, right? Similarly, if you put r2, r is equal to 2, then a3 will be equal to, right, 3 to the 6, that's going to be 6 plus 8, that's going to be 14. Okay, so 6 plus 10, that's going to be 16, right? Then a1, so 14 by 16, then 1 is replaced by a1 is replaced by this value sorry, this is not going to be a1. So on putting r is equal to 2, this is going to be a2, right? This is going to be a2. And if you replace this value of a2 by this value of a2, here you can see. So if you put here a2, then what you going to have? a2 is equal to 44 by 65 a0, right? That's what we have got. Now if you cancel, then 7 2 is 14, 2 8 is 16, right? Then 2 4 is 8, sorry, yes, then that's gonna be 11, right? So okay, then 77 130, and that's what we have got, right? So again we're gonna put these values in equation number 2, right? So in this equation, okay, in this equation, so from equation number 2, if you expand the value of y, what we should get, equation number 2 implies y is equal to a0 x to the power m plus, then you're gonna have a1 is equal a1 into x to the power m plus 1, then you're gonna have a2 x to the power m plus 2, then a3 x to the power m plus 3, and so on. That's what we're gonna have. Now you see, so let us put these values using these values in equation number 2. In equation number 2, so in equation number 2, I have written here. Then this a0 will be replaced by, so what is the value of a0 here? So sorry, a0 remains a0. So what is the value of a1? So replace the value of a1 by this value 4 by 5 a0. So let me put here 4 by 5 a0. And if you replace the m, if you replace this m by 7 by 3, so 7 by 3 plus 1, 7 by 3 plus 1, that's going to be 10 by 3, right? So here we're going to have 10 by 3. Just wait. So you can keep this m as a 7 by 3. So here let us put 7 by 3 here, 7 by 3 plus 1. Let us put here 7 by 3 plus 2, 7 by 3 plus 2, and let us keep this 7 by 3 plus 3, and so on. And let us put the value of a2 here. So a2 is nothing but this is a2. A2 is equal to 44 by 65 a0. So let us replace this by 44 divided by 65 a0, right? So this is just wait, let me, there should be a0, okay. So here you see, then let us, here we had a3, let us put the value of a3. This is the value of a3, here you can see, let's put here. So a3, instead of a3 we're gonna write 77 by 130 a0. That's what we're gonna get, right? So now you see, this is the solution, another solution for m is equal to 7 by 3, right? So we have got the two solutions. One is this, here you can see. So let me copy this one as well. This is the first solution we have got. So let me paste here. For this is next one is this. So this is the next value. So here you can see, this is the two results we have got. So here you can see, let me go back to this slide. Here you can see, so in this case, for this case 1, the solution should be of this form, right? So here m1 we have got m1 is equal to 0, and m2 we have got 7 by 3, right? M2 we have got 7 by 3, and we have to use these values here, and c1 and c2, right? So let me go back to the last slide. Here you can see, so therefore y is equal to, so what are we going to have? Y c1 into y for m is equal to 0 plus c2 into y for m is equal to 7/3. Now if we put those values here, then and here you can see we can take a naught common from all the terms, right? Here should be also a naught, right? Just wait, let me go back to this slide. So I missed this a naught here, there should be a naught. Okay, so just wait. So taking common, we're gonna have c1 a naught, and within bracket we're gonna have 1 plus 1/3 x plus 2/9 x square plus 14/81 x cube plus dot 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 so on. Similarly, you can take a naught x to the power 7/3 common from all the terms here, right? And doing so, what we're gonna have? We're gonna have c2 a naught x to the power 7/3. Then if you take this common, and you're gonna have here 1 plus, let me write these things here below, this 1 plus, and on taking these things common from the second term, what we're gonna have? We're gonna have x to the power 1 here and 4/5, right? 4/5 into x to the power 1, that means simply x. Similarly, from the third term, there will be 44/65 and x to the power 2, right? 44/65 x to the power 2, and similarly we're going to have 77/130 x to the power 3 plus dot 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 so on. So this is our solution. Okay, so you can replace these constant terms by a, capital A, if you want, or you can keep this as it is if you want keep, and you can replace this by b. Okay, so that is your answer. So in the next video we're gonna solve another equation by Frobenius method. In the next video we're gonna solve another equation using same method, but for different cases, for case number 2. So wait for the second video, next part. So it's gonna appear at the end of this video if it is uploaded. Okay, when it will be uploaded, it's gonna appear at the end of this screen of this video. Okay, just you need to click this, otherwise not. Okay, unless I upload that next one, it's not gonna appear. But